Okay, this video for preparing or getting ready for calculus is going to be on the average rate of change. We're going to have one that should follow this video that's going to be related to finding the difference quotient, which is actually just a little bit further advanced from this topic. So to start, I've kind of got it defined right here as saying the average rate of change, also commonly just shorthand AROC, of a function f of x over the interval from a to b is going to be the change in the function's output divided by the change in the function's input. So it probably sounds familiar. It's really just the slope formula, but we write it with function notation because we're not just only talking about a line anymore. So we can be talking about any function that we want to deal with. So the formula looks like this. So you can see you have the change in the function's output, f of b minus f of a, over the change in the function's input, which is b minus a. And so your interval here would be the closed interval from A to B. And so we say that it's really just going to be the slope of the secant line, which is just the line connecting the 2 points, A f of A and B f of B on the graph, like seen here in this picture. So the yellow graph is going to be your function. Here's your 2 points when x is A and B. So that's your interval from A to B. And then if you look at the blue line, that is your secant line. And so what we're really doing is finding the change in y over change in x, or the change in output over the change in input, which is just the slope of the secant line. Now, as you advance forward, there's applications of this, and there's also going to be a connection to a concept in calculus where you're going to bounce off of this and kind of expand further. So a common application I just kind of mentioned over here, the most popular one that's usually used in a Calculus 1 course is going to be thought of as average speed or velocity. So we're going to, eventually you'll connect that. Now here's a worked out example for you where you're going to be given a function and then you're going to be asked to find a average rate of change, and you'll be given some interval, right? So if you see x is equal to 1 to x is equal to 4, you can think of that as your interval from A to B. So what we want to do is we want to find f of 4 and f of 1. So you need to find the function values at each of those x values. And so you can do that by taking each of those values and plugging it back into your f of x. So f of 4 is going to be 16, right? 4 squared. And f of 1 is going to be 1, or 1 squared. And then as soon as you have all of your values, you can just substitute into the formula from up above right here. So we've got f of b, which is f of 4, minus f of a, which is f of 1, over b minus a, which would be 4 minus 1. So we get 16 minus 1 over 3, which is 15 over 3, which is 5. Now, if you look back at the picture that goes with this particular problem, you can see here's the part of the graph of x squared, and this is the point 1, 1, and 416. And we really just found the slope of that secant line, which came out to be 5. And if we had to interpret that in words, we would say that on average, the function is increasing by 5 units for every 1 unit increase in x over that given interval from 1 to 4. Okay. And so that's important, the interpretation, because when you actually start to put some units with it and put it in an application form, you want to understand what it actually means. So we're going to do two examples. The first one, you have the function square root of x, so your square root function, and we're going to look at the interval from x equals 1 to x equals 9. So like I said, the first thing you want to think of is your interval is from 1 to 9. So we need to find f of 1 and f of 9. Okay, so f of 1 is 1. F of 9 will be the square root of 9, which is 3. And then you can easily set up your average rate of change by doing this. So you have f of 9 minus f of 1 over 9 minus 1. And so we know that's going to be 3 minus 1 over 9 minus 1, which is 8. So you have 2 over 8 or 1 over 4. Okay, so that is finding the average rate of change. And of course, you can label it like so. And then the second example we'll do very similar. So your interval now is from 1 to 2. So if we do f of 1, that's 1 over 1, which is just 1. And then if we do f of 2, that's 1 over 2. And so the average rate of change is going to be your f of 2 minus your f of 1 over 2 minus 1, which in this case is 1/2 minus 1 over 1. And then that's just going to be a negative 1/2 over 1, which is just negative 1/2. Now, when you have a negative, that means you have a decreasing average rate of change. And so that's okay. That can happen, right? Because think of it, remember, we could have a negative slope. So we'll continue on in the next video. We'll work on defining the difference quotient. So we'll just expand on this. So in the meantime, keep practicing.